Gentlemen, so the first thing that you're going to work on today is we're going to take some notes. This is the title, Choosing the Best Graphing Method. This should be going in your notes. Make sure you copy everything down because this is going to help you do your assignment today as well. Now, first off, this is us going back. Okay, we finished up with our last lesson, which you just turned in, and now we're going back to graphing again. But we're not only going to look at graphing, but we're going to start to see, do people really understand what's the best choice in any situation? All right, so take a look. First thing is, some graphs will be easier to do with just plain old table like we did much earlier back in December. We also learned some shortcuts like slope-intercept, and that's specifically for when on the equation y is by itself. It's already in slope-intercept form, and so we use this method that's in our notes. Or something's in standard form, and this is the one where we use zeros, and the giveaway here is that the x's and the y's are on the same side of the equation. Okay, so just a refresher. We can graph with the table, which is kind of doing it the long way. There's slope-intercept, but y has to be by itself. And then there's standard form, where the x's and the y's are the same. All right, so let's take a look at some examples that I've scripted out. Okay, and again, copy these down because not only is this your notes, but this is going to help you do the work today. All right, so here's our first one. Number one, all the instructions will say is graph this equation. Okay, so it's your job today to not only remember how to graph this, but what would be the best method. Okay, 4x minus 8y equals 24. So the first thing you want to do is you want to ask yourself, all right, well, which of these three ways that we've learned does it most look like? All right, well, hopefully I'm thinking that you picked standard form, because the giveaway here is that the x's and the y's are on the same side of the equation. Okay, 4x minus 8y on the left, and just the answer on the other equals 24. Okay, so that means that this is best done using our standard form methods, which, if you recall, is, let me get the pen here, to use the zeros to find the x-intercept and the y-intercept. Okay, and this should go in your notes, and this is what the work looks like if you remember. For the x-intercept, it's a simple matter of plugging a 0 in for y. Okay, so the 0 would go here, 8 times 0 would disappear, so really my only work is to solve what's left over. 4x equals 24, divide both sides by 4, so x equals 6. So 6, 0 is my x-intercept. Now I do the same thing for the y-intercept. I go back, start over. I plug in a 0, but this time I plug a 0 in for x. Whatever intercept I'm looking for, I plug 0 for the other variable. So 4 times 0 disappears, and I get negative 8y equals 24. Divide both sides by negative 8, we get y is negative 3. So 0, negative 3 would go here, and then all I have to do is graph it, which would look something close to this. All right. But I think the big thing here is, one, use this as an opportunity to practice your graphing methods, but then more importantly, start to understand what's the best method possible, because we always want to be working smarter, not harder. And for this one, this is working smarter. It's the fastest way we could graph this particular equation. Okay, so now let's try a couple more. Here's number 2. Again, your work today will just say graph this equation. It doesn't tell you what method to use. That's for you to figure out. All right, now when you look at this, you got to ask yourself, well, what would be easiest? And again, going back to here, should I do a table? Should I do slope-intercept? Or should I do standard form like the last example? All right, so make a decision for yourself. What about this is the giveaway that kind of tells you the method? Now what I'm hoping is that you're looking at this and you're noticing y is by itself. Okay, which puts this in slope-intercept form. Y equals mx plus b. So that means these numbers mean something. It means I don't have to do any work. I can just pull the numbers, where m, the slope, is whatever's next to x, in this case the 4. And the y-intercept, or what we call b, is the number off by itself, in this case the negative 6. Alright, so I have a slope of 4, a y-intercept of negative 6, and again, with this method, slope-intercept, that's enough to graph it. I find my y-intercept of negative 6 on the y-axis, which is right here. And the slope is 4, but of course I need that as a fraction. I need rise and run, so 4 over 1. So here I'm going to rise 4, run 1, rise 4, run 1, so on and so forth. Connect the lines with a straight ruler, and there's my graph. Okay, so notice, because number 1 was in standard form, this was the quickest way to graph it with the zeros. But then, on number 2, it was in slope-intercept form, so this became the fastest method for graphing. So again, not just knowing how to do the work, but making the right choice about what work to do. Alright, let's try number 3. Get this one down in our notes. Graph y equals -3. Now for this one's kind of one of those special cases where, first off, I'm hoping you notice x doesn't seem to be anywhere on the equation. So this was one that we found the best way to do it was to do a table. And you kind of have to remember what this means in terms of doing it with a table. When we did a table, you get to pick x. So let's say I pick x to be, I don't know, 2. What this equation is telling us is that regardless of the fact that you pick x equals 2, since there's no place to plug it in, it's just flat out saying that no matter what, y is going to be -3. So it doesn't matter what your input number is, the output number will always be -3. I could pick 0. Doesn't make a difference. My output number is still -3. I could pick -8. The y coordinate that which spits out is still -3. Alright, so in this case the table's the easiest thing to do, because then I can just go over here and do, let's see, 2, -3, which would be right here. I could do 0, -3. I could do -8, -3. And what I'll eventually get is a bunch of dots down here at the bottom. Oops, wrong button. That makes a straight horizontal line right there. Okay, so here we've seen all our 3 methods and where we might use them. Standard form and using the zeros, slope-intercept and just pulling the slope and the y-intercept, and then even sometimes going back to the table and just filling out a table and graphing those points. Alright, let's look at one last case. And again, get this in your notes. Graph the equation 2y equals 3x plus 12. Now, when you look at this one, what I'm kind of hoping that you're looking at and thinking to yourself is, well, that's a little confusing because unless I'm wrong, this isn't in any one of the forms we've learned. So, in fact, you're right. Okay, so sometimes, just like on your work today, you're going to have to put it in the right form. So you have to be asking yourself, is it easier to get y by itself and make it look like y equals mx plus b, or is it easier to get x and y on the same side of the equation, like standard form, ax plus by, and then the plain old number on the other side? So you have to ask yourself the question, which is easier? So think about that for a little bit. Okay, now in this particular case, I'm hoping everyone in class just chose one of these because, in fact, this one, it's just as easy to do both. Okay, so in fact, in your notes, I'd like to see the work for both, but in your work today, you only have to do one or the other. But take a look. I know some of you are probably thinking, oh, it's easiest to get y by itself because all I have to do is to divide by 2. So my work would look like this. Y equals, because the 2's cancel, 3x divided by 2 is just 3 halves x plus 12 divided by 2. Notice how everything's getting divided by 2 would be 6. Alright, so when I graph this, I would go a y-intercept of 6 up 3 over 2. Okay, and I'm kind of out of graph space, so what I'm going to do is I'm going to go backwards, but just follow along the same line. So it'd be back 3, or sorry, down 3 and back 2, so that it all falls along the same lines. Down 3, back 2. Alright, I make my line, and I'm good to go. Okay, now even though we finished, what I'm going to do is I'm going to change pen color. I'm going to put this one in blue. Let's say some of you thought, no, I think this is better to be done in standard form. Okay, and I think you'd be right. There's one easy move to put this in standard form, which is to get these x's over to the other side. So my work there might look something like this. These cancel, and on the left side I get negative 3x plus 2y equals 12. And then I do the whole zeros thing. For the x-intercept, I plug a 0 in for y. The 2y disappears, and I get negative 3x equals 12. And so x would be negative 4. Negative 4 is 0. And we're assuming this work isn't here. But notice where our dot ends up. Same place on the line as the rest of it. Then I plug a 0 in for x.
Second round, neighborhood kids go to the bus. Second round, go to the bus.
All right, sorry for that interruption. All right, so x is 0. Negative 3 times 0 disappears, so I get 2y equals 12, just this part of the equation. If I solve that, y is 6. So I get 6 right here. And again, draw my line. But notice, whether you chose to do it slope-intercept form, or maybe the person working next to you chose to do it with standard form, you're going to get the same answer. Okay, so it's partly a matter of personal preference of what you like, but it's also a matter of which is it easier to get it, what form to get it into. Sometimes it's going to be slope-intercept, sometimes it's going to be standard, or in cases like this, both are doable. Okay, so this is your work today. Okay, hopefully you copied all this down in your notes so you can refer to it. Okay, but these problems are also on your work, so make sure you go back to your notes and just copy down the work from here, and then continue in the same packet and use these notes to decide what's the best way to graph something and to practice your graphing techniques. All right, go ahead, get the worksheet and get started.